Okay, let's start with micro frontends with Qwik. Never been easier. This morning in the conference, I saw Manfred. So I want to tell you a story. This morning, Manfred showed up this nice slide with the native federation as a layer, basic layer for abstraction. And I'm this guy here that is implementing a Vite module federation. So I was in vacation and I saw this tweet about Zachary. It was August 2022. I was in vacation, as I mentioned, and then I decided to jump into the module federation with Vite. So Manfred helped me a lot to create this amazing plugin. And this plugin allows us to use native federation with Svelte, Vue, React, Vue 3, Vue 4, Vue 2, sorry. But if someone want to, in the future, maybe there will be Vue 4, and someone want to maybe adopt in native federation, I need to adapt this library for that. So I think if we have an external dependency like native federation, if we want then to support the new features, then you are struggling a lot with the external dependency because you have to maintain both of the dependency, the Vue, for example, and the native federation one. But I want to deep dive into the journey. I create the Giorgio Boa Vite module federation. Then Zachary asked me to join the module federation Vite, and then I move this repo into the module federation organization. And I think it's a great things because into module federation we have a lot of great developers and great support. So you can find the library there. But as I mentioned before, if we have a new version of Vue, React, or something that we are using, we need to support to have the support also for the native federation part. But now we are here to talking about Qwik, and why we are talking about another framework. Basically, because with Qwik, we don't have the needs of external dependency, native federation, stuff like that. And I will deep dive into all the process to show you how and why we don't need external dependency, and module federation with Qwik is really, really easy. So let's start to say that usually we create a big application with a lot of images, a lot of dependency, a lot of interactions. And then with a modern setup, with a great connection, we are really, really fast to load all the bundle, all the dependency, assets, so on and so forth. But if we are in a low connectivity area, then it's hard to download all the application, all the external micro frontends. So we end up with a slow application, basically. And the result, most of the time, is a loading, a spinner, or whatever. And another bad result is that most of the site does not pass the core web vitals because we have bad performances and other bad metrics. Because the JavaScript, this is a graphic that shows the JavaScript on the page over time. And as you can see, is going up, 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 and up. So if you are creating a module federation, a module application with module federation, maybe your final application load a lot of JavaScript. And if we run PageSpeed Insights, this is a great tool to understand the performances of our application. We can see that performances, maybe SEO and best practice are bad. And the bad of all of this is that time to interactive is, for most of the websites, a lot of time. So 23 seconds to time to interactive is really, really bad. You can run these metrics from this site, Builder.io Performance Insights, and these websites show up the more or less the same things, but with a plus. This website show you that if you optimize the images, the time to interactive is will be 8 seconds. If you optimize the CSS, 7 seconds, and if you finally optimize the JavaScript, the time to interactive is 2 seconds. Okay, so with this tool, Builder.io run these metrics with all against all these websites. The font is small, but in the first position we have Amazon.com, Walmart, Apple, and many other great e-commerce websites. And as you can see from these metrics, if we finally optimize in this column here, if we finally optimize the JavaScript, the results are really great. So the bottleneck basically is the JavaScript. But let's dive into some theory of how we do the server-side rendering. The most of the frameworks, SvelteKit, Next, and Solid Start, Astro, and many others do the hydration process. But what is the hydration? So hydration is basically a workaround, because we have the HTML, we have this blank page here, and then we ship the JavaScript to the browser, we execute the JavaScript, and then we render a snapshot of our websites. From this, when the user click, we have the HTML, and then we have the page, okay? And this appears faster, but under the hood is going to re-execute all the application and is going to reconcile all the event listener. And then finally, we are able to click. So in the end, appears fast, but becomes slower, but is slower. And we do a double execution of the JavaScript in the first part to calculate the snapshot, and in the second part to reconcile all the HTML. So basically the hydration cost during the startup, when we include also a micro frontends in our page, we need to do this hydration. With Astro we have partial hydration, but we have always to struggle with this hydration process. And if we look at the performances, hydration cost during the startup, it's really, really heavy. But let's run into a hydration demo. I prepare for you a server-side rendering application with a framework. And basically what I've done from the starter of Next.js, but I decided to use Next.js only because it's the most popular or one of the most popular. But you can have this demo also with SvelteKit and many other server-side rendering framework. And then I add this hydration check, this JavaScript, and inside of the page, into the document, inside of the head, I put this hydration check to prove the hydration process. So what we are doing a set interval every 1 millisecond, so really fast. And if the type of window is different from undefined, so we are running this code into the browser, into the server, type of window is equal to undefined, so we are running this code into the browser. We are looking for my button. I create a button with this particular ID here. Okay, and then basically with this button I console log the my button on click. So this method here is helping us to know if the button has listener or not. So I console log this button on click, and if button on click is different to null, I clear the interval basically. So if I can start the application in dev mode or in production mode, but the result remains the same. So if I look for my application at localhost 300, okay, we have the application into the other screen. We can move here. Let me check. Okay, this is an application, and then as you can see from the console, if I refresh, you can have a lot of on-click null. So basically the framework is going to render a snapshot, and then after the client rendering, we add a console log in our homepage to show the client rendering, and then we finally the framework attach the listener. So basically, if we are able to interact with the page before the client rendering, nothing happens because there are no listener for this button. And this is a problem because basically we need to wait for this hydration part, and then we're struggling with low performances. Because as you can see here, we are in React DOM. Let me show you this. We are in the React DOM source code. And here is going to reconcile all the things, attach the listener, and so on and so forth. So basically, this is the iteration. What about the resumability? Resumability is the new mental model that Qwik bring us to the front end and give us the possibility to run our Qwik application inside of a micro-frontends architecture without any problem. So resumability, as I mentioned, is a Qwik features, is a Qwik mental model. And imagine to have this beautiful application with a lot of interaction. The first things that you are shipping to the browser are HTML and CSS with no JavaScript, only 1 kilobyte of JavaScript, only 1 kilobyte. That this kilobyte is looking for the user interaction, is looking for events. So as soon as the user click on the order detail, this kilobyte of JavaScript take the events and download the chunk and download and execute the JavaScript to interact with the page. So the first render is really fast because we have HTML and CSS, and only if the user click on a button or in a particular part of our application, we are executing our code, our JavaScript, and also any other dependency that we had involved in our application. So if we are a dependency from Day.js for a specific part of code, only if we interact with that particular part of the page, we are paying for the execution of the external library. So hydration is different from the resumability. This is the hydration, as we mentioned before. The resumability is HTML and the page, and then if the user click on the page, we are executing the JavaScript. This kilobyte of JavaScript that we are shipping in this particular part of our flow is looking for events and executing the JavaScript. And then if we interact with the other part of the page, of course, we are executing more and more JavaScript. But of course, the performances are really different. Okay, we have a lot of integration with Qwik with the edge, the cloud. So Netlify, Google Cloud, Vercel, Azure, Cloudflare. A lot of integration because the framework is really fast, and the edge give us the possibility to have really great performances. Let's jump to a demo of Qwik. So let me move to my Visual Studio Code. Here I create a quick example. So here we have a Qwik application straight from the starter. So we have the roots folder, so is file-based routing. And then we have our pages are JSX. So as you can see here is more or less similar to some other framework, the only things that is different is that we have this special API component dollar, and then we have this dollar sign. These are the specific from Qwik, and these are markers that are saying, hey, here we can extract this part and create a specific chunk for this specific JavaScript. So it's a marker for the building process to extract the specific code to a different file. So it's a marker to split our code at build time. So basically, when we are creating a normal application, we end up with a big JavaScript to ship to the browser. With Qwik, we have small chunks. Okay, so if we run a build of Qwik npm run build, we are looking at under the hood. By the way, we are using Vite with some special plugin that the Qwik core team build on top of Vite. And the building process create a lot of JavaScript. By the way, we can configure the building process to create one or multiple JavaScript, because the team is working to the template part and also to the building part. So we, with just one configuration, we can change the building output, and this is a great thing. So we have this specific chunk, and then for every dollar, Qwik is going to create a bundle of chunks or a specific chunk itself. Under the hood, we have Vite, and then we have a Rust code that is going to traversing all our component and create this specific output. But if we run the preview mode of the framework of this application, then we can move ourselves to these specific endpoints. This is the application. And then if we go to the network tab, if I refresh, here we are filtering for JavaScript, only JavaScript. As you can see, we have no JavaScript. I can scroll, and then only if I click on this counter here is this component. Here we saw a little bit before is a button under here, and then my handle click is this function. So we are using Lodash and Day.js, and we are increase our counter. So we are using two external dependency. And if I click on the counter, as you can see here, we are downloading, basically, we are executing this JavaScript with the two console log. And of course, we have the console log into the browser. But we are also loading external dependency. So Lodash, and then on the bottom, we have also Day.js. So basically, only if we interact, as I mentioned before, with some specific area, with some specific dependency, we pay for them. In a production build, we have a service worker that is going to download all the chunks. So is going to pre-buffering, more or less like a YouTube video. We are looking for the minute 5, but under the hood, YouTube is going to buffering also 6 and 7 and 8 and so on. So in a production build, the service worker is going to pre-buffering all the chunks, and then if we interact with a specific area, we are eating the service worker to get this specific information, this specific file. So basically, we are not downloading the chunk when we interact, but the JavaScript is already in our cache. Okay, but I would like to show you why is working without any event listener. So I basically create a different branch, is site generation, static site generation. Okay, so with Qwik you can do static site generation, and I create a dist folder with all the build. Okay, then I can run my application. So I need to build my application, build, great. And here we have our build, our index, 404 HTML. As you can see, it's really minified. But I create two files here to replace from in this folder to show you how it works under the hood. Because here, let me check, quick loader. We have a script. The 1 kilobyte of JavaScript we mentioned before is this script. As you can see, it's minified, so I can't show you how it works, but I create a JavaScript with the same code, but without the mimification, so I can deep dive into all the process. So I need to replace this index file with this other one. So here we have the index, and at the bottom I simply replace the quick loader, the 1 kilobyte of JavaScript we saw before minified, with this loader JavaScript. So let's start the application. So to start the application, I can use this command here. The port is different. Okay, the application is the same. Okay, let me go here. Okay, into the source code. Here is our loader JavaScript. So the quick loader, I put some breakpoint to show you how it works. So basically, let me do like this. New page is better to show you in a new page. Okay, so let's refresh the source code loader. Oh, this one here. Okay, perfect. So if I refresh, basically the first thing that is doing is going to look for these quick events. Into the elements, we have these quick events because the framework is recognized that we can do some click events. So it's going to use this function here, a push. And a push under the hood is attach an event listener to the document and to the window. So basically we have an event listener, but at the edge of our application, not into the specific element, but at the edge. Okay, so if we run this, great. Only if I click here, is going to do a few things, but it end up here with this specific event. The type is click. Let's go a little bit further. Okay, so the element, as you can see, is this one. So the target of the event is this one. And then if we go on, okay, we are dispatching the event. If we move a little bit on, here we have an attribute name, because the framework during the build time is adding this on-click attribute for buttons, on visible, on over. Every events are recognized by the building process and is going to attach the specific attribute to the button. So we have this on click, but here is going to do something that is really magic. So it's going to get the attribute on click, is going to, let's move a little bit on. So here is going to get the attribute value. So this is the value of the attribute, as we saw before, is this value here. Okay, and then if we move on, okay, a little bit on, so it's going to get the URL from this specific value, and then it's going to grab the symbol name. So now in this specific point, it's going to import the URL, and then after this import is going to get the information, is going to execute the JavaScript basically. Because an import, if we do an import like this for a specific JavaScript, is going to do an HTTP request to a specific URL. And then we grab the information and we are doing the things that we need to do. So basically, it's the magic to don't do the iteration, but use a different mental model to grab all the chunks that we are needing. And basically, we don't have a listener into the specific elements. So now we can go on. Okay. And that's all. This is the mental model of Qwik that is going to be really fast, performant, with less JavaScript to the front end. Okay, but we are looking for Qwik, but we are in a micro frontends conference, so soon we will see the implementation of micro frontends with Qwik. Hold on. So resumability is more or less like a virtual machine. So we have a virtual machine, we can log our user, we can open Visual Studio Code, we can pause the virtual machine and pass this specific virtual machine to a colleague, and then it can replay the virtual machine without login or open application because are already there. So basically we are doing more or less the same with HTML with this new Qwik mental model. So with a classic approach, with the amount of JavaScript is growing as the site require more functionality. So we are adding a new page, we are adding a new section. We need more JavaScript. Our bundle is getting bigger and bigger. With this approach, the correlation is broken because only if the user interact with a specific part of the page, we are executing the JavaScript. So basically, if you have a small application, if you have a big one, the performance is really the same because we need to ship only 1 kilobyte of JavaScript. That is our quick loader we saw and debug before. So with a traditional framework, the execute JavaScript over the time is at the top. With a resumable framework, we can have these kind of steps, because if we interact with a new part of the application, we execute that specific code. Okay, so micro frontends with Qwik. I create an example of micro frontends with Qwik. Is open source in this specific repo, Giorgio Boa Qwik micro frontends. Here screenshots, and you can scan this QR code if you want to go straight to the repo. But I would like to show you an example, the code. So let's have a demo. Let's go to the Visual Studio Code here, and let's open the Qwik micro frontends application. So basically here we have a monorepo with NX. We have 3 applications: the host that is going to load the home, and then we have the checkout with multiple routes. So the home is horizontal split, so we are loading the home inside of the host, And then we have the checkout that is vertical split. So there is a page for the checkout summary, and checkout payment. We have a shared folder with constants and some information about the remotes. And we have a UI library. So we are sharing the components through all the micro frontends. With this amazing extension of NX, we are able to run all the application. So let's serve all. So we are running 3 Qwik application. We have, of course, different ports. This one is the host. In this other specific one, we have the home, and is the horizontal split, so is inside of the host. And then we have in the other part here, checkout. We have the checkout, we have the checkout payment, and we have the checkout summary. So this is a specific vertical split with inside of this micro frontends we have multiple routes. Okay, so the final result is this one with this host. We can, of course, this button here is from the host, and this is the horizontal split. We can communicate from micro frontends. I decided to use custom events in this specific case. But if I click here, I can move all the application to the checkout summary. And then if I click to payment, I can move the user to the payment part. And then here I add a counter just to show the quick interactivity and the application is working correctly. But how I implement all this feature, all this architecture? So basically, here we have these 3 applications. We have the host, and inside of the host we have all the configuration. So instead of Vite, here I can stop all the servers and move this here to have more space. Instead of this server, we have a little bit of configuration, and we have a specific configuration in Vite for proxy. So basically here we are saying if you are hitting the /home, please redirect all the traffic to that specific application, so with a different port, and grab the HTML and CSS and put this HTML and CSS into the host. So with a specific configuration for the proxy, we are able to redirect all the traffic and get back the information from the micro frontends. All this code is open source, so if you would like to give a feedback, give your help, you are able to do, and I'm so happy to get more reports or information from you. So inside of this specific route, this is the home page of the host. We have this counter we saw before, and then we have this remote micro frontends component. These components receive the name of the remote. Instead of this home, we have basically the URL. So we have here the remotes. We are saying home is name home with this specific URL. Of course, this information, you can grab this information from an external endpoint, because if we are doing this in a specific file, we are coupling all the things. You need to expose this information from an external URL, and this is, I think, the best approach. So get the information from outside. But for this specific case, I create this constant remote with the name home and this URL, and checkout with this another URL. So into the component we saw before the remote micro frontends. So we are saying, okay, please load these micro frontends from this endpoint, and please remove the loader. This is an important part for Qwik integration, because we have the Qwik loader we saw before. Every application has one Qwik loader, of course, because this is the nature of the framework. And we are saying, please remove the loader from the application you are going to integrate with the other one, to prevent the possibility to have more event listener and stuff like that. So the remote micro frontends is a simple component, let me say, and we are saying, please, with these specific elements straight from Qwik library, we are doing a streaming of the HTML. So we are composing the URL, we are appending a loader false if we don't want the loader, and then we are basically fetching the remote URL, and then chunk by chunk we are writing the stream to the HTML, so to the host HTML. So if I put a console log here, console.log, you will see into the terminal all the HTML and CSS, because with Qwik we don't need any JavaScript basically, because we have only HTML and CSS, so we can basically writing them into the page and all will work correctly. And if you notice, we aren't using any external dependency in our package JSON. We aren't using module federation and stuff like that. It's a normal behavior of the framework. So for this specific integration, so the horizontal split we are doing with this remote micro frontends. But if we would like to move our user to another micro frontends, basically in the cart counter, okay, we are doing the magic with a simple anchor tag with href. So we are doing we are moving our user to the /checkout/summary, and under the hood the proxy is going to do the magic, because it's going to redirect all the traffic to the other micro frontends, is grabbing the response and put all the information to the browser. So let's start again all the application. Okay. Okay, so this specific part we are loading with the remote micro frontends component. We are, as I mentioned, we dialogue, we interact from one micro frontends to another with custom events. Maybe I can show you, but it's fancy stuff. So here we have this use on document. This is the name of the events, and we are doing a counter basically. And into the, let me check, into the home, if we are looking for this specific event, this is the host. Okay, and we are emitting a custom event with some detail. And then if we click here, we are doing an href to /checkout. We are moving here. We have these micro frontends, and here we are doing a anchor, a link as before to checkout/payment. Okay, so that's all for this demo, and let's jump back into these into the slides. So this is the second implementation I created for Qwik and Microfrontends. The first one I created in collaboration with the Qwik team and Cloudflare team. You can find the first implementation I did a few months ago, maybe in the end of the last year, 2022. This is my GitHub with this Qwik first implementation of Microfrontends. The website, maybe you can jump into this repo. Here, the website where you can see all the architecture in action. And this is a great article that Cloudflare team create after this implementation. So if we jump into the browser, here we have the repo of the first implementation of Qwik with Microfrontends. You can obviously look at this implementation to get more information about all the stuff. And here a warning that the example with more functionality is in the version 2, basically. As you can see, we had a lot of contributors. This is the demo. The first implementation of the microfrontends. All these microfrontends are on Cloudflare, so are on the edge. Because if we click on this one, here we have the header, and here we have the hero. And then if we scroll, we have the product, is another microfrontend. And only if we scroll into the last part, we are seeing these microfrontends. This microfrontends is loaded only if the user scroll till the visible part of these microfrontends. So if I refresh, you can see that boom. Maybe I can open the network. Maybe. Okay, refresh. And then if I scroll, you can see that it's going to load all the microfrontends and the recent reviews. So if I do this, okay, it's really fast, but I think you get the feature I would like to explain. Okay, so, and let's check also the article. The article here. This is the article that Cloudflare wrote for the microfrontends. You can have also a QR code if you want to scan the article and read it after the conference. And it's going to show more or less the things that we are so few minutes ago. Okay. Let's talk a little bit about the Qwik community. This is the official website of Qwik. Here you can find Discord server for the community. The community of Qwik is a hidden feature of the without code. It's a feature without code, let me say, because it's very welcoming and helpful if you have any question, any problems. The community is really happy to help you. And here a library, maybe we can check. I'm a maintainer of this library. Is a design library for Qwik. We can check maybe Qwik UI under the Qwikifier organization. In this organization, we are adding a lot of libraries. I create the Qwik image to optimize the images when you are using Qwik. So to show the placeholder and then load an optimized image for your web page. And then we create also this Qwik UI library that is a design library. It's design library that use the Qwik API, because as you saw in this presentation, Qwik is really different from the other framework and use a different mental model to do things. Okay, if you are curious about Qwik, you can scan this QR code, and this is a free Qwik course. So if you would like to know a little bit more about Qwik, you can look at this amazing course about Qwik. I'm Giorgio Boa. I'm full stack developer for Clarinet. You can find me on Twitter. My handle is at Giorgio_Boa, or you can find me on LinkedIn as well with my name and surname. I'm really happy to connect with different developers, share things, and many other stuff. If you'd like to follow me, I'm so happy. I would usually post and repost things about microfrontends and frontend in general. Thanks for listening, and let's jump into the Q&A.
Awesome. Thanks a lot for the talk and the nice demos about Qwik. Really always a pleasure. Okay, we had a couple of questions, so let's go over them.
Yeah, sure.
So let's wait for the questions. All right, so Rob asked, what if the click handler needs to load a large chunk? Would it not make it seem like the button is not interactive?
Oh, this is an interesting question. I think if you have a big chunk to load, I think you end up with the same problem that you can have with a normal framework, I think. But I suggest you to try with a Qwik, because optimize really well your JavaScript code. Not is not changing your JavaScript code, but is bundling without changing the code, but is bundling in a optimized way. So I would like to encourage you to try with Qwik.
Mm. And potentially you can then, if you detect something like that, you can always make it smaller, right? Like you do chunk splitting right now.
Yeah.
You could also see, why is it so large, this one handler? Can I also lazy load parts in there, right? And already get my handling going and do other things. So I guess there are always strategies, right? Yeah. Okay, next question. When not to use Qwik or resumability? Don't give me. What are the downsides? Because it sounds a bit like too good to be true.
Yeah, it's too good to be true. Honestly, I think it's a game changer. When I saw how it works under the hood, I think there is no downsides. Maybe the only part that is not covered is the mobile one, because if you have React Native, for example, you can share component from your React front-end part to the native one. We don't have the native component. Of course, it works on mobile device, of course, but we don't have a Qwik native framework.
Even though I don't think React Native, I mean, it always sounds so nice, but it only has like this mental model of React. Because if you have a component, a real world React component that has any mention of an HTML thing like diff, you're already out. You can't just use it in React Native, right? So it really, and at some part, I mean, directly or indirectly, you're using that usually on the web. So you would really have already a set of components that, then when you compile for the web, uses this one set that relates to HTML.
I see.
So basically, you can't just transport things over there as well, right? So the only thing,
I'm not too much into React Native, but as you mentioned, as I understand, you ended up with the two implementation of the same components, basically.
Potentially, yeah. I mean, or at least you would need to have a shared set of component libraries, which then, depending on what mode you transpile to or compile at, would use either, the component library for React Native, just using React Native elements, or the one for the web using web elements like divs and so on, right? So, yeah. Because there is no div on mobile. It's completely different components, right? It's native components. That is what React Native does. At the end, it juggles just native components around for you, but you write a nice JavaScript and everything, you get all the benefits. So, yeah. So it's a different beast than standard React.
I see. Another great thing is that the core team is managing also the bundling part. So if you have the same application that needs to run in a high connectivity area, so you can have a lot of chunks, and the same application is going to run into no connectivity area. Basically, you can simply configure like a slider, let me say, configure the bundling stuff, and the building process is going to produce one JavaScript that with the service worker you can cache at the startup.
Cool. That's a real
without change any code, any of your code, basically.
Nice. Let's get in the next question. We can still have time for a couple more. So for Nikolai, was it taken into account that overall many requests for small chunks are heavier in size than less requests with bigger chunks? In other terms, what is the rationale that determines chunk sizes?
This is a difficult question to answer. Basically, under the hood is going to bundling many chunks together. Under the hood is going to look for a relationship. So if I change something in this component, maybe there is a correlation with this other component. So let's bundle the two chunks together. Or if you configure your building process to create only few chunks, the Rust part and Vite part is going to bundling all together. So basically, you don't have a waterfall with a lot of chunks in production, because the optimization process will bundle the chunks together in a reasonable way.
Nice. Okay, let's get maybe one or two more questions in. From Sondre, on a high level, it seems that React Server Components tries to solve similar issues where it will not include JavaScript unless interactivity is needed. How would it compare to Qwik?
Okay, this is another great question. So basically, React Server Component is going to say you, okay, this component will not change at runtime, so let's create a server component for this. And then in your tree, you can have a child that is a client component. So you can change, you can have a search bar, you can have an input in this component. But if your PM, PO, or your customer would like to have in the server component, would like to change the things, would like to move the input in the one level up, you end up to refactoring of your code, because the server component is not the server component anymore. So you end up with a bigger refactoring of your application. And also this architecture work in a different mode, because if you have a client component and a top level client component, when you change something on the top level, you ends up with tree re-rendering. With Qwik is different. You don't have to re-render all the tree, but you will change in a chirurgical way only the component, because we have a signal that is a great API taken from Solid that is going to change only that specific node without rendering all the tree. So it's completely different in the end. And then in server component, an annoying things that I saw when I used this React server component is that you have to think about what is client, what is server. It's a ownership of the developer to say this is a client part, this is a server part. I can do this part, this feature because it's a client. I cannot do this specific API because can't use this specific API because it's a server. So it's with Qwik you don't have to think about nothing because the framework will help you to optimize your code.
Great. Maybe one last question and do the ruffle. Oh, okay, that's a question for me. Will there be a post-conference feedback questionnaire? Yes, we will send out a link to something tomorrow, I guess. Of course, we appreciate your feedback and want to hear how you felt the event went in general and what we could do in the future to improve such events, or if we should continue doing them. All right. Okay, last question now for you. Is Qwik faster than SolidJS?
SolidJS has hydration. Solid Start is a server-side rendering of SolidJS, has hydration. Ryan Carniato, the creator of Solid, is helping a lot Qwik team. I don't think it's a race, but it's only different, I think.